All right, so this is the more algebra and trig review problems for Calculus 1. And I'm just starting off, so I'm starting where we left off. And this is problem number 5, and these deal with inequalities. Part A says, so we're going to solve for x. And for an inequality, you're going to have multiple solutions. It's not just going to be one particular value. And for these, we're going to express the answer as an interval. All right, so for 5a, if I were to solve something like this, so I have x times x minus 1 times x plus 2 greater than 0. What I'm going to find is, so I'm going to first treat the inequality sign as an equal sign. And these are going to give me, I guess I would call them test values, is what this will give me. So this will give some test values. So for this example, if I treat it as an equal sign, so the x and then x minus 1, x plus 2 equal to 0, I have 3 different factors, which means I'm going to have 3 different scenarios or 3 different cases. And I'll write x1 for the first one, and that's going to be if focusing on just x itself, the first factor, that would be x equal to 0. The second one, if I focus on x minus 1, so this will be my x minus 1, that's going to be, I'll say x2, if I set that equal to 0, you get 1. x2 is going to be 1, right? Because you do x minus 1 equal to 0, and you have to add 1 to both sides. The third one, so I call that x3. If I set that equal to 0, I get negative 2. All right, so these are my test values. And from the test values, I create intervals. And you could think of it like a number line. Let's see, so if I have a number line of 0 is in the middle, so my positive values to the right, negative values to the left. So here's going to be negative 2, 1. That's to the right of 0, so that's going to be where my other test value is. And as far as the possible solutions as the intervals go, now keep in mind, you can't actually have these numbers be the solution to the problem. You can't. All right, be solutions. And the reason why, so we say why not, and that's because you have a greater than sign in the problem. So you have a greater than sign, not a greater than or equal to sign. Now, if you had the greater than or equal to, since it's two possibilities, it could be greater than or equal to, then I could have those be possible solutions. Okay, so now that we know these test values are not going to be part of our solutions, but from these test values, we can form intervals. And the intervals, I could have possible solutions would be to the left of -2, so all of these values. But I don't include -2, right? Because I'm saying, I already said before that I'm not including that. So I put an open dot around -2. That means to not include -2. All right, then possible scenarios, my other test value is 0, but I can't have it actually be 0 as my solution. So I can have everything that's in between the two. And then I can also have everything that's between 0 and 1. So that's going to be an open dot around 1. So everything that's in between there. And then I have everything that's to the right of 1. So as far as the intervals go, I can have everything that's to the left of -2, which goes to -infinity, to -2, and I put a parentheses around -2 because I have an open dot around -2. I'm not including that. I can also have between -2 and 0, and then I can have between 0 and 1, and then the last I can have 1, and then everything to the right of 1. That's 1 to positive infinity. All right, these are my possible intervals that can be part of the solution. And then to tell whether which interval is going to be your actual solution, you're going to pick some value in each interval. To determine if that interval is valid for the equation or inequality. All right, and I'll use a different color, and from these intervals, I'm going to pick some value. I'll use blue. So actually, I'll use red. So I'll pick a value that's in each interval. So one of them I could pick, let's say I did -3, right? That's in this area. And then between -2 and 0, I can pick -1. So it's up to you what you pick. And I'm going to pick -1. Between 0 and 1, I can pick 1/2. And then from 1 to positive infinity doesn't matter. Again, you just pick some value that's in the interval, and I'm going to pick 2. All right, and I'm going to plug these in for x. Into the original problem, which was x times x minus 1, x plus 2 greater than 0, and see if it's valid. All right, so if I plug -3, then that's going to be -3 times -3 minus 1 times -3 plus 2. And then I have to ask myself, is this greater than 0? That's the question. Well, this is going to be, so this is a negative. This -3 minus 1 is negative. Negative 3 plus 2, that's negative. If you multiply an odd number of negative numbers, it's going to be negative. So we're multiplying 3 negative numbers. That's going to be negative. It don't really necessarily matter what the value is, just the sign. Since it's negative, this is not greater than 0. So this is not greater than 0. So it's false when you choose negative 3. Okay, so I'm going to say, so false. So then since it's false, I exclude the possible interval of negative infinity to negative 2. All right, now the next value I use is negative 1. And I plug it in for x, so it's instead of x times x minus 1 times x plus 2, it's going to be negative 1 times negative 1 minus 1 times negative 1 plus 2. And then it's asked, is that greater than 0? All right, so this is a negative. This is negative. Negative times negative is positive. And then negative 1 plus 2, that's positive. So you have a negative times a negative. These two make positive. And then times positive is a positive, which that's greater than 0. So that's true. All right, so since that worked, that means this is part of my solution. All right, then I just keep doing this process for the other ones. So the remaining 2 are 1/2 and 2. So let me try 1/2 now. And again, it's just going to be plugging in 1/2, so it'll be 1/2 times 1/2 minus 1 times 1/2 plus 2. I ask, is that greater than 0? All right, so this is positive times negative. And then 1/2 plus 2, that's positive. Since it's an odd number of negatives, positive times positive, that's going to be a negative number. And that's not greater than 0, right? Because it's negative. All right, so this one's false. So since that didn't work, I get rid of the possible interval of 0 to 1/2. Now I check the remaining one, 1 to positive infinity. So I plug in 2. So it'll be 2 times 2 minus 1, and then instead of 1/2 plus 2, it'll be 2 plus 2. And then I ask, is that greater than 0? All right, so this is positive times a positive times positive. So that's going to be a positive number. So yeah, that's greater than 0. So that's true. So that means our interval, where it goes from 1 to positive infinity, that's part of our solution. right, so therefore I conjoin the two. So conjoining the two intervals, we have, so it's possibly going to be -2 to 0, that interval, and then possibly 1 to positive infinity. Those are that's my solution. And to conjoin it together, you're going to use this symbol. It stands for union. All right, this should be review. This represents union. It's the union of the two intervals. All right, so that's going to be my answer. All right, so to recap what I just did, I did this real in depth as far as writing the steps. So this was the problem. What I did first was I treat it as an equal sign. That will give me some, what I call them, test values. All right, so if I replace the greater than with an equal sign, that gave me 3 test values. x1 is 0, x2 is 1, x3 is -2. And that's by setting each one of these factors equal to 0. Now, I said you can't actually have these test values be solutions themselves. And the reason why not was because we have a greater than sign instead of a greater than or equal to sign. All right, so from these test values, so draw a number line. This isn't necessary to do. You don't have to do this. You just need to form the intervals. And from forming the intervals from the number line, I had the possibilities were -infinity to -2, -2 to 0, 0 to 1, and then 1 to positive infinity. Those are my 4 intervals, which means if I'm going to test each interval to see if they're actually part of the solution, I have to pick some value in each interval. So that's why I just picked -3. You could have picked -2.5. Doesn't necessarily matter. Or you could pick -4, whatever you think is easy to plug in. So I did -3, -1, 1/2, and 2 as the 4 values corresponding to each interval. And then for each value, I plug it in for x into our original problem, where it's x times x minus 1 times x plus 2 greater than 0. And then I ask myself, after I plug it in, is this valid? Is it greater than 0? So for instance, for -3, I had it as -3 times -3 minus 1 times -3 plus 2, which turns into a negative number times a negative number times another negative number. When you multiply 3 negative numbers, that's going to be negative, which means it's not greater than 0. So that's a false statement. All right, so if there's an odd number of negative numbers, like 1, 3, 5, 7, that you're multiplying together, that's going to stay negative. If there's an even number of negative numbers that you're multiplying together, like multiplying -2 times -4, what have you, that turns into positive. All right, and I continue the same process, just plugging each one, and then just seeing, really it's the sign. Notice I didn't actually calculate what the actual numerical value is. I only cared about the sign to determine if it's greater than 0. All right, and once I did that, so for instance, when you plug -1 in, you got it to be a positive in the end, which is greater than 0. So that -1 came from the interval -2 to 0. So that, why I circled that, that means that was part of our actual solution. All right, and the other interval that it was correct for was 1 to positive infinity. All right, then I conjoin these two intervals, and I use a union sign to conjoin it. All right, union means the word or. So throughout this course, I'll be using union. You might see something like this. That means intersection. I didn't use the intersection sign because -2 to 0, 1 to infinity, the intersection, they don't intersect anywhere. All right, that's how I did that problem. Now I'm going to move on to the next inequality type of problem. And these next ones have absolute value signs. And I'll say from algebra, from one of the algebra classes you've taken, you'd have to know how you handle absolute value with an inequality sign. And your possible solutions, so I'd say if you ever have it in the following cases, like if I have absolute value of u less than a, you can translate this out of an absolute value and it translates into -a less than u less than a. Now, if we have the absolute value of u less than or equal to a, it's similar. It's just going to be less than or equal to signs instead of just less than. All right, those are those two cases. Now there's a third case. If it's a greater than sign, that means you're going to have two possibilities. You're either going to have u is greater than a, or u is less than -a. And then the fourth one, if you have absolute value of u greater than or equal to a, it's similar to number 3. It's just going to be, so it's going to be u greater than or equal to a, or u is less than or equal to -a. That's how you handle these type of problems. All right, so I would probably write this down somewhere, are you, to have that in your notes. Now this problem 5, your u is x minus 4, a is 3, so that just translates into so I'm following case 1, so it's going to be -3 less than x minus 4 less than +3. That just falls into this category. All right, and then I just add 4. So you want to get x by itself. So then that's going to give me, so -3 plus 4 is 1, so that's 1 less than x less than 3 plus 4 is 7. All right, this is the inequality version of the answer as an interval. This is parentheses 1, and I use parentheses around 7 since they're both just less than signs. All right, and they usually want the interval answer. All right, that's 5B, 5C. So it's the 2 times absolute value of x plus 1 minus 6. And I think it was greater than or equal to 2. Yeah, so before using the definition, so before applying the stuff above, you need to get the absolute value term by itself on one side. All right, so to get the absolute value term, in this case is absolute value of x plus 1, what I'm going to do first is bring the -6 over, so it adds 6 to both sides. That way those cancel out. Then I have 2 times the absolute value of x plus 1 greater than or equal to 8. Then if I want to get absolute value of x plus 1 by itself, I'm going to divide by 2. So now I have absolute value of x plus 1 greater than or equal to 4. All right, now I'm going to apply the stuff in green that's above. All right, and you focus on the sign. Well, what sign do I have? So I have a greater than or equal to sign, and that matches case 4. All right, so I'm using the fact that the absolute value greater than or equal to a translates into u greater than or equal to a, or u's less than or equal to negative a. So in our case, u is x plus 1, a is 4. So that's going to translate into x plus 1 greater than or equal to 4, or x plus 1 less than or equal to negative 4. So I have these two cases. And I'm putting a strong emphasis on the word or. All right, I'm not using the word and. That's going to be important when I get down to the final solution. So for both of these, I just subtract 1. So I have x greater than or equal to 3, or negative 4 minus 1, that's going to make negative 5, or x is less than or equal to negative 5. All right, now as an inequality, so if you want to envision this is a number line, here's 0, say negative 5's right there, and say 3's right there. So my possibilities, I could have negative x less than or equal to negative 5 because of the equal to sign, putting a closed dot around negative 5, and then because it's less than, I go forever to the right, into the negative infinity direction. All right, this is my x less than or equal to negative 5 case. The other case is 3. It has an equal to sign, put a closed dot on that, and then I go forever to the right because of the greater than sign. All right, so that's just a way to envision the solution as an interval, because that's what they're going to want. You go left to right on the number line. So the first case was less than or equal to negative 5. So that goes from negative infinity to negative 5. And I put a bracket around it because of the equal to part of the inequality sign. And since there's an or, we're conjoining the two, I'm going to use the union sign. And the other case is going from 3 to positive infinity. So I put a bracket around 3, and then off to positive infinity. And again, I use union. And you could remember to like note, use the union sign whenever it's the word or. right, so that's going to be the solution or answer to this question. And again, you don't have to draw the number line. I just did it for sake of demonstrating. And what I did in the problem, just to recap, is I get the absolute value term by itself first, and that incorporated adding 6 to both sides and then dividing by 2. Then I had the absolute value term by itself where it's greater than or equal to 4. Now I apply one of these 4 definitions, and it was number 4 because the sign matched that one. All right, and then I broke it up into these 2 cases. And from those 2 cases, I got x by itself. All right, so then the next one, 5D. All right, and this is the last one for this problem. Let's see, so sorry, I forgot what it was. 2 times the absolute value, 3x plus 1, and then plus 8. And I think it was less than 2, or less than 4. All right, and I'm still gonna try to get the absolute value term by itself first. So still isolate absolute value term by itself first. Meaning I'm gonna subtract 8 from both sides. All right, so subtracting 8. So I have 2 times the absolute value of 3x plus 1 less than negative 4. And now I divide both sides by 2. So I have the absolute value of 3x plus 1 less than negative 4 divided by 2 is negative 2. All right, I'm going to stop here because I'm not going to actually use the definition because it's going to require our knowledge of absolute value. Now, I'll put this in green. So a comment, we know that when you take an absolute value of some quantity, that it will result in either a positive number or 0. For example, just saying if we had the absolute value of negative 3, we know that turned into positive 3. All right, it turns into positive. So knowing this fact, so this is just by the definition of absolute value, we can conclude that absolute value of some quantity will never be less than or equal to a negative number. So it's not true that if you have an absolute value of some quantity, that's going to be less than some negative number. That's impossible because of what the definition of absolute value is. So this is impossible. So for our question, we have at this stage 3x plus 1, absolute value of that, less than a negative 2. And so it really doesn't matter what's inside the absolute value sign, since we know it's going to result into a positive number. But since I have it being absolute value of something less than a negative number, this is never true. Therefore, we would say there's no solution. All right, so the answer is no solution. All right, so that's I just wrote out the very long, in-depth explanation. You don't have to give the explanation. I just figured all you have to write down from here is just no solution. All right, so because the absolute value, if you take the absolute value of some quantity, it's always going to be either a positive number or 0. Like for instance, the absolute value of -3, that turns into +3. Like it's never going to be equal to -3 when you take its absolute value. Knowing this fact, we can conclude that the absolute value of some quantity will never be less than or equal to a negative number. So I'm saying it's not true, and I just wrote down absolute value of some quantity less than negative number. That's impossible. So for our question, we have that scenario. We have absolute value of 3x plus 1. That's like our quantities, 3x plus 1, less than -2, which, like I said, that's going to be no solution. All right, so that's the answer. It's no solution. Now, just for a, so I'm going to continue this in a part 3, but before I move on, I will say, make another comment that if it had been let's say 3x plus 1 greater than -2, we would say that this is always true. It doesn't matter what x is, it's going to always be true. Since absolute value is going to be positive. Since it's positive, it's greater than a negative number. So had this been the case, we would say there's infinitely many solutions. As an interval, we would say that's negative infinity to positive infinity. All right, I'm just saying as a comment, that's not what the problem had, but I'm just saying if it was a greater than sign right there, That's always true that an absolute value of some quantity is going to be greater than a negative number, since we know the absolute value results in a positive number. And a positive number is always greater than a negative number. So that's why I would say it's infinitely many solutions. It doesn't matter what x is going to be, since you're taking the absolute value of this some quantity involving x. And that quantity itself is positive. All right, so the answer would have been negative infinity to positive infinity if that were the case. All right, so I'm going to end the video here and continue this in a part 3. So see next video for part 3 on algebra and trig review. Just because I feel like this video is probably long enough and I only handled the inequality type of problems. Next video is going to be different. So I'll stop it there.